Hey there, everyone. So this is your last lesson of the year, 10.5 Pythagorean Theorem. I can use the Pythagorean Theorem to find missing side lengths of right triangles. So a few things that are important. First of all, you need to know what the Pythagorean Theorem is, right? We need to be able to write it, which most of you are pretty good at writing the Pythagorean Theorem. You probably remember it from middle school, but do we remember how to use it? So what do we use it for? To find missing side lengths. And more specifically, they have to be of right triangles. Pythagorean theorem only works for right triangles, not any other kind. So they have to have that 90-degree angle. You usually see a box in the corner. So like so, it has to be a right triangle. So it's if you know two of the sides and you don't know the third side, then you can use the Pythagorean theorem. Okay? So let's look at the Pythagorean theorem itself. Okay. So open up your notes. The Pythagorean theorem is a rule of right triangles that tells us that the square of the hypotenuse is equal to the sum of the square of the legs. And there it is. Most of you remembered a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. So let me draw a picture, and I do recommend you doing the same. A picture here on the side so that you know when you're looking at a picture where is the hypotenuse and where are the legs. So here's my right triangle. The legs are the two sides that make up the right angle. So this is a leg and this is a leg. Whatever's across from the right angle, that is your hypotenuse. Okay, so pretty important that you know those things. So the legs are called A and B, and the hypotenuse is called C. It doesn't matter which leg is A and which leg is B, but the hypotenuse must be the C in the equation, okay? So I'll even highlight it. The A and B are the two legs, and then the C must be the hypotenuse. Okay? So how did they figure this out? Okay, so trying to find the missing side of a triangle, you can see here there's an area visual that kind of helps us to see what it stands for. So we have a triangle, a right triangle right here where the side lengths are 3, 4, and 5. So if we drew, this is 3 units long, and if we drew a square here, a 3 by 3 square, as well as a 4 by 4 square and a 5 by 5 square, and found the areas of all of them. So remember that area is length times width. So in this case, a square, 3 times 3 is 9. The area of this square right here is 9. The area of the bottom square, 4 times 4, 16. And the area of the large square, 5 times 5, is 25. And basically what we just did was a squared plus b squared equals c squared. We said the areas of the two smaller squares added up to the area of the larger square, because 9 plus 16 does in fact equal 25. So you could make a model like this if you needed to help you with it. Okay. It doesn't help so much if our answers are not beautiful whole numbers. So we'll look at all kinds. So let's go ahead and look at example number 1. Make sure, guys, that you're listening to this video and taking excellent notes. So the side that's missing here is x. We don't know the hypotenuse. So it's important to label each of your pictures. So the two legs are A and B, and the hypotenuse then would be C. So you can see the equation already set up for you. 5 squared plus 12 squared equals x squared. So let's find out what this is here. What is 5 squared plus 12 squared? We can use our calculator. 5, here's the squared button, plus 12 squared, enter. So 169. So we have 169 equals x squared. The x squared is still there. Now, how do I get rid of squared? The opposite of a squared, to get rid of a squared, is a square root. So we take the square root of both sides, and that makes the squared go away. It's kind of like the squared cancels out the square root. So there's just an x left. So first, let's see, is 169 a perfect square? Let's actually find the square root of it. Control, and then x squared. See, it creates that square root. Type in 169. Lucky us, it is a perfect square. It does give us a whole number, 13. So x equals 13. We now know the missing side length. These two sides were 5 and 12, and the hypotenuse, which is always the longest side, by the way, is 13. Okay. So take a moment, pause the video, and try example number 1 and 2. Try them on your own. Okay, let's review the first example. So first, I determined which were my two legs. That would be the 8 and the 6, because remember, they are the two shorter sides. They are the sides that make up the right angle. The angle across, or the side across from the right angle, D, that is your hypotenuse. So 8 squared plus 6 squared equals D squared. 8 squared is 64. 6 squared is 36. You can type them in your calculator, remember? Add them together and we get 100. Then I took the square root of 100 in my calculator and I got 10. So the missing side was 10. And remember, check to make sure that your answer makes sense. The hypotenuse should always be the longest side. And 10 is definitely bigger than 6 and 8. Now, number 2 was different because this time I did not give you both legs. One of the legs is 9, the other leg is E. We don't know that leg, but we do know the hypotenuse. So I highlighted the two that go together, 9 squared plus E squared. And then the other side of the equation is 15 squared, because 15 is the hypotenuse. So this one was slightly differently because when we squared them, we couldn't just add them together. We squared the 9 and got 81, 9 times 9. We squared 15. 15 times 15 is 225. But to get E squared alone, we had to minus that 81. So we minused 81 from both sides and got 144. And then took the square root of 144 and got that the missing side length was 12. This time we were solving for one of the legs as opposed to solving for the hypotenuse. So that was the missing leg of that right triangle. All right, let's go ahead and look at that third example, our next example, because it's going to be quite different. Okay, here we go. So this one we're going to look at together because this one is different than the previous. Let's see how it's different. Okay, so looking at this, we know our two side lengths, our legs are 5 and 5, and the hypotenuse is what we don't know. So 5 squared plus 5 squared equals f squared. 5 squared plus 5 squared. So 5 squared is 25. 5 squared is also 25, and when we add them together, we do get 50. Now to find f, remember we take the square root of both sides to get rid of that squared. Now it's just f. So when we type in the square root of 50 into our calculator, let's see what happens. Control x squared. Square root of 50. What do we get? It is a decimal. Oh no. Oh no. So we do not write our answer as decimals. We're going to write it in a simplified radical format. Now we have learned how to do that. So let's recall how to do that. We have a list of perfect squares, which maybe you might want to write here at the top somewhere. 2 times 2 is 4. 3 times 3 is 9. 16. 5 times 5 is 25. 36. 49. 64. That's 8 times 8. 9 times 9 is 81, 100, 121, 144, and remember it goes on and on and on, okay? So we have a lot of perfect squares, okay? Remember we talked about which perfect square is a factor of 50, and I can see that 25 is a factor of 50. So we're going to rewrite square root of 50 as square root of 25 times square root of 2, because 25 times 2 is indeed 50. The square root of 25, we can find the square root of. The square root of 25 is 5. This is something we learned back in Unit 8 when we were doing the quadratic formula. Okay. Alrighty. We are actually going to skip question number 4. Okay, so you do not need to do it. We're moving on to question 5. Okay, let's do question 5 together, and then I'm going to have you try questions 6 and 7 on your own. Okay, so question 5. Remember, I highlight, you may want to circle which two are the legs. So you remember, these are my two legs. So 1 squared plus h squared equals 2 squared, because 2 is the hypotenuse. So 1 squared means 1 times 1. 2 squared means 2 times 2. Remember, we're trying to get h alone, so we need to minus the 1 from both sides. And then to get rid of the squared, remember we take the square root of both sides. So h is the square root of 3. There are none of those perfect squares we had at the top. If you look at our list, none of those divide evenly into 3. So it's just going to remain the square root of 3. Take a moment to try examples 6 and 7. Pause the video. Okay, everyone, here's example 6. So the x and the 13 were the two legs, and the 15 was the hypotenuse. When I squared them, you can see what I got, and then I minused the 169 from both sides. Then to get rid of the squared, remember you always have to take the square root of both sides. So the x is now alone, but we still have square root of 56 that we need to simplify. 56 is not a number on our list up here, remember? So, but we need to see, do any of these numbers divide into 56? You want the biggest one that does. So in my calculator, I took 56 and I started dividing by that list of numbers. And you can see here, I divided by 4 and it worked. I got a whole number. So 4 times 14 is 56, and that's where I got these two. And the square root of 4 is 2. So my final answer was 2 radical 14. And the last problem was interesting, and I want to finish it up with you. The two legs were 6 and 5, so 6 squared plus 5 squared equals the hypotenuse x squared. When you add them together, we get 61. So I'm going to go through in my calculator with you how I would see if this can be simplified or not. Are there any from our list that's up here, that divide into 61? So I'm going to start with 49 because all of these other numbers are too large. 64, 81, 100, none of them will divide into 61. So I'm going to start with 49. So 61 divided by 49. Nope, not a whole number. 61 divided by 36. Remember, these numbers I'm dividing it by are part of my list that I have at the top of my notes. 61 divided by 25. No, 61 divided by 16. 61 divided by 9. 61 divided by 4. None of them work. None of the numbers that were on this list divided into 61, which means that square root of 61 is just my answer. I'm done. There is nothing else I can do. It's my final answer. Okay, guys, if you have any questions about any of the problems that were on this video, make sure to ask your teacher.